tomorrow. Tomorrow and Friday next day. Alright, so guys, here's where, just to remind you, all the way back to Thursday. Not including the whole isosceles triangle and equilateral triangle stuff, but where you guys would have left off before was the definition of congruent, well, probably didn't put polygons, but congruent polygons. And where we were at Thursday was if I give you a question where there's two polygons, so your two shapes, triangle, quadrilateral, pentagon, whatever. For you to be able to show that they're both congruent to each other, you had to have, right, all the corresponding sides and angles be congruent to each other. That was all the pairs. So if it was a hexagon, you had 6 pairs of those things. Triangle, there were 3 pairs of each. Pentagons, 5 pairs, so on. Alright. Triangles, you don't necessarily have to do it. There's shorter ways to go about it. Because there's limiting factors where it's impossible to draw a triangle that's not congruent if you're giving a certain set of information. So instead of having to do all the pairs, I'm just going to have to do some of the pairs. It shortens the work, essentially. Okay, so there's going to be 5 ways we're dealing with. Well, I'll probably put off 5, but there's 4 that are like the main ways. These are the ways that you're going to work most of the problems. The 5th way is limited to right triangles. So if you don't even have a right triangles in your problem, the 5th way needs to not even exist. What you guys need to do is on that sheet I gave you that had the on the front of it was the ways to prove lines parallel. Okay, there should have been 2 sheets, the cheat sheet or whatever I called it. This guy should go on the back side of it because I'm also going to give you common pictures that show up quite a bit, and I'll give you the properties that go with those specific pictures. The way I'm going to do these guys is I'll go theorem by theorem, postulate by postulate, whatever. Whether or not you get it as a theorem or postulate right now doesn't necessarily matter. What's going to matter is you have to be able to identify, the pairs of things that are mentioned here in order to show that the triangles are congruent. You kind of catch on as we go. Alright, so the first one is side, side, side. Congruency, I believe this one's a postulate. Okay? But again, you getting postulate again doesn't necessarily matter. Alright, so the way these things are worded, the title of these, this is telling you when they say side, 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 they're telling you you need 1, 2, 3 pairs of corresponding sides that are congruent. I don't need to know anything about the angles, which again, that goes against the definition of congruency. Okay, however, with triangles, it's impossible to take 3 side lengths and make a different triangle than one set. So if I had side lengths that are 3, 4, and 5, it's always going to make the exact same triangle. It's impossible for me to draw a different triangle that has side lengths of 3, 4, and 5. Okay? Alright, so this is, every time I write a word up here, this represents like a pair of corresponding sides. Like in this case, it's sides. We're going to also have angles. So if I see 2 triangles, alright, just again, for example, I'm just making up like generic triangles with things marked. And I say, hey, I'm looking at these 2 triangles. I've got 1 pair of sides marked congruent, 2 pairs, 3 pairs. I know those are the same triangle. They're drawn in different places, but they're congruent to each other. They're identical. So the name is telling you what you need to see marked in the picture. However many things are there, there's always going to be 3 things. In this case, it's 3 sides. So however many words are up there, that's what you got to find in the triangle. Alright, the way you guys are going to write this when you do your proofs, you're not going to actually write the full thing out. You'll write it as that. Like this right here will be like a reason in terms of your proof. Probably going to be a final reason. Okay? So now again, keep in mind, right? All of this stuff that we're about to put up there is to show that two triangles are congruent to each other. So that means that you're going to have a problem either asking you, are the triangles congruent? Or when we do the proofs, it might be prove that triangle ABC is congruent to DEF. So, okay? And just remember, right, if I put labels on the sides, like with the letters, when I wrote out my congruency statement, the order of the second set has to match up with the order of the first one. So if I write A first, that means I need the letter that corresponds to A to come next. So if A is here, that's going to correspond to F. Because A is formed by the side that's got the 2 marks and the 3 marks, so I got to do the same thing there. B is going to correspond to D, and then E would be. Alright, second one you guys can write out. Again, I'm going to write it long ways first. Side, angle, side. Congruency. I don't remember offhand. Postulate, maybe? I think the first ones are, and then the last ones aren't. Yeah, I think the last one isn't, right? Alright, so again, each word here is representing a pair of corresponding things you need to find. So this means this is one pair of corresponding sides, 2 pairs of corresponding sides, and then 1 pair of corresponding angles. The way this is written is important, okay, in the fact that this angle has to be connected to those 2 sides. Okay, this is called, I'll write it up here, this is called the included angle. Okay, now, side note from that, which I'll write, I don't know, I'll draw it over here. Give me 3 letters.
ABC.
Oh, come on. Just for example of what an included angle is, okay? Included angle just means it's formed by 2 sides. So if I looked at angle C, like angle C is an included angle, say for sides, it's for the 2 sides that create it. It's like this side creates it and so does that. So that means this is an included angle for those 2 sides. These 2 are connected to that angle. And these. Okay. All right. Now, the way this would look, for you to see all this stuff marked off. Again, just 2 triangles. Again, I would need 2 sets of sides that are congruent. So that'd be 1 side and 2 sides there. Then for me to apply this theorem, again, I need the angle that is like connected to the 2 sides. So I would have to do some kind of work to show that that angle and that one were congruent. That would give me my side angle side. Alright, so again, the biggest thing is making sure that if you're going to apply this theorem, which again, you guys are going to write it that way, right? You're not actually going to write the words out. But make sure that this angle here has to be in contact with the 2 sides you know are congruent. If not, you're either not going to be able to do it or there might be another theorem to use. Okay? So like if you had, if this angle was maybe up there, there'd be no way for me to say that those two are congruent based on what's marked. All right, you just got to make sure that the angle is connected to it. All right, the next two both revolve around you having two angles on the side. Okay, so two pairs of angles, one pair of sides. The ordering of the letters is really the only difference between them. And it's just going to matter on if the side is called an included side, meaning it's shoved between two angles, or it's a non-included side. All right, so your third way, we'll do with the included one first, is angle, side angle. And again, this was, okay, so now, again, this side here, it's stuck in between the two angles, so it's considered an included side. So again, included just means it has to be connected to both those things at the same time. Alright, so if you need to see like a picture of it, if I had those two angles marked congruent, like if I had those two pairs, the side that's considered included would be this side here, because this side is in contact with both those angles at the same time. So is that one. So if I saw something kind of marked in that direction, I could say, I know that this triangle and this one are congruent to each other because that postulate. And again, this is how you guys are writing it. You just write the ASA. You don't have to write the full angle side angle up. Okay, and then look, I'll piggyback this on pretty quick. The last of the main four. So again, the main four are the ones you're really focusing on. And this is angle, angle, side. Alright, so again, both of these involve two pairs of angles on one side. The difference is the ordering of it. So in this case, the side is simply connected to one angle, not two. Okay? This one is a congruency, I believe this is the theorem. Right? So the way this would have to look, let's say I marked off those exact same angles I had above it. But now in this case, I need a pair of sides that is connected to one of the congruent angles. So like if I had this side here, I would need that one there because it's connected to the angle that's got the one little arc on it. Alright? If I had this one here, I would need that one there. Alright, the biggest thing is here, this side that you have, this pair of sides, say it only touches one angle. Keep that in mind. This one here is going to be connected to both of them. That's the main difference between them, is just where that side is sitting. So again, this is the included side, this is the non-included side. This is what it's called. Alright. Those four are going to be the four that you focus on majority of the time. Okay? Alright, so now the fifth way, 5. You want to write it, guys, if you're going to write it, like, write it either off to the side, or, like, make it extremely clear that this is for right triangles only. Okay? This is the only way that this specific theorem is going to work. Alright, so number 5 is called the HL. Well, I'll write out words first. So this is hypotenuse congruency should be a theorem. Okay? Alright, so, and again, the way you guys are writing it, oh, I didn't write for this. This is AS. And the way you guys will write this is HL. Okay? Alright, so this one here, since it has that word in it, right? The only type of triangles that have hypotenuses are right triangles, so this is only for right triangles. If you don't have right triangles, this doesn't exist. Just forget about it. Blow it out of your head. Alright? Also, for this, you have to have a hypotenuse mark congruent and then one of the legs. Remember, these are both legs. It doesn't matter. You just have to have one of them. Okay? So the only time, again, make it very clear in your paper, this is only for right triangles. And you have to have something involving the longest side or this doesn't apply. Okay, so it's very specific and when you can utilize this. Now again, just because this is for right triangles doesn't mean every single time you see a right triangle you're going to use it. Because for this to work, you have to have the longest side. Okay, and even if they give you the longest, you might use one of the other ones anyway. It might be quicker. Okay, this is just an alternate to doing any of these problems, if you have a right triangle, or enough information there. Alright, now, before we get into, like, you guys actually looking at a few diagrams and seeing if you can match it up to one of those 5, between today and tomorrow, I'll give you all these like common diagrams you guys are going to see. Because you guys got to realize there's a very limited number of situations they can give you, and these things are going to repeat a lot. And there's properties that are going to repeat a lot. And the reason they repeat is because they give you pairs of congruent angles or sides pretty quickly. And what I'm going to try and do is I'll give you pictures that and diagrams that are going to come up quite a bit. This isn't going to account for every single thing. Obviously, there's always going to be some things that could change. And really the key for you writing these proofs out when we get to it is have the paper out that sheet out that has all the junk on it, or your own piece of paper that has all this stuff on it. Okay? Like, you got the 5 ways, things to look for. You're going to have pictures to look for. The pictures are going to give you properties which, like, in turn, give you reasons on a proof. All this stuff together is going to help you with the writing of the proofs. That we'll spend the next few days on. Okay, so the first one we'll do vertical angles first. Okay, so the first one is the diagrams where you'll see vertical angles being congruent. Okay, now again, look, these first few I'm going to add that this, remember, is like a reason. Okay, your statements are going to be saying which 2 angles are the vertical angles, which in turn are going to be the congruent ones. You don't actually have to say that they're vertical angles because it's in the picture. You just say that they're congruent. Vertical angles, guys, they have to kind of make this little bow tie shape, okay? Or if it's going this direction, you know, like an hourglass kind of thing, whatever. All right, but if you ever see that, basically from now until the end of the book, you're going to have vertical angles here and here. And I'm just going to put a 1 and 2 in there just for the sake of writing it out. It's much shorter. You guys can always do that. Even if they got letters on there, if you want to use like 1s and 2s just to shorten the amount of stuff you're writing, that's fine. Just make sure you do it on the picture too. Like if I had that, like if I wanted to tell someone that was angle ACB, but again I was writing something that was long and I didn't feel like writing all those, I just throw a 1 on there and I can say that's angle 1 and you're good to go. Okay? Alright, so like if I saw those pictures, like one of the first things I would do, even if I don't know what the proof is asking, is saying, I see that picture, there's vertical angles. I would put a statement out saying angle 1 is congruent to angle 2, or whatever the lettering is, or whatever. Okay, and your reason will be vertical angles. That gives you one step in a proof right there just by looking at the picture, even if I don't know where it's going. The picture is going to give you pretty much all the steps, and the more you see this stuff, the better off you'll be. Right? But also remember with this, guys, they have to be two straight lines. Like if they try and give you something like this, these aren't vertical angles there, because those are not just two straight lines. There's 3 lines there. All right, so just make sure that you have it so that it's something like that where these two are going together. All right, next thing that's going to pop up a lot. Again, I'm going to write this. This will be number 2. And this is going to be, I'll put a reason here. So this one is going to be applying the reflexive property congruency. So again, this is a reason. You can abbreviate it with just REF. That's fine. I need to see at least that, though. If you remember, right, reflexive property, this is the thing that says something's equal to itself or congruent to itself, which at the time, when you say it, it sounds really stupid because, yeah, if something's equal to itself, you don't know where it applies. In this case, it's going to help out because it gives you a pair of either sides or angles that are congruent without doing any work. All right, the pictures where this will come up. For this, you have to have, you're going to see like an overlap somewhere. Okay? Meaning either a side or an angle is going to be completely in both the triangles at the same time. Pictures like that, where they got triangles shoved back to back. That's an overlap. That's what I say is an overlap. Okay? There's a side that's in both the triangles at the exact same time, meaning technically that's a pair of sides, which are good, because remember, we want pairs of angles and we want pairs of sides here. Okay? So I'll put letters on this one. So let's say boom. So this right here, even though it's one line or one segment, it's in both the triangles, so I can make that pair of congruent sides. So this would be like a statement I would write. That would be a reason I would put. So anything where it's like back-to-back or overlapping is considered. Majority of the time, this is going to apply for sides. All right? You'll see some like this. Okay, where this side is probably part of both of them. All right. There's a few where they're going to try and throw you off some, like this. You got a picture that looks like that? The first thing I would suggest is make sure, like when you get to the problem, that you actually look at the triangles they're asking about, because I've seen pictures like this one where they have this part in there just to screw with you, and they only want you to look at these two triangles. But if they ask you to look at the entire thing, so like ABC and DBC, you would have a reflexive side right there. Okay. Then you'd also, I guess, to stem off of this one, they'd have some that look like a kite kind of shape, like right there. The only time you guys will see angles is like that, where they'd be asking about that triangle and that triangle. Okay, you'd have an angle at the top that is a reflexive one. Angles should never be put as reflexive unless you see a picture that kind of resembles that one. Okay, and then let's say it's an A, then you could say angle A is congruent to angle A. Alright, and again, it's still reflexive. Majority of the time, though, this is going to give you congruent sides 95% of the time, I would say. Okay? Very rarely will you see this one. But it's possible, so put it up there.